Okay, so we've just added a population of people. We've given people this visual representation, and with homes, we give them this visual representation. We've added a population of people in it. Now we're going to add a population of homes. How do we do that? Drag it in, and we're going to call it homes. Population of agents. And it should be 400 agents. Okay? Good. I'd like you to run the model. What should we see now? People and separate from them, homes. You see something like that? Do you see that? Okay, TA help? Who else needs TA help? Okay, a TA help in front? Other people?
So this one automatically applies.
TA help middle? Oh, I'm sorry. Go ahead and we'll, yeah.
So it automatically applies the random layout
to both of them. Yeah, and that's set in those properties. You can tell to which populations it's applied. Yeah. I'm sorry? Okay, that's a great question. And remind me your name? Serge? Yeah. Okay. So Serge asked, how do you tell which is in front of the other? This is the key. First, I'll answer Robin's question about where the why it's applying the random layout to both. If you scroll down here, what you'll find here is that you can actually set the agents you want to place in the environment. And so because you're placing both of these in here, it's applying the random layout to both. And now with respect to Serge's question, this ordering here is set. If you go to main, you notice that this guy is in front of the person. If we want to make the person in front of it, we could say order send to back, and now the person will be in the front. And that will allow the persons to not be occluded by the houses. Now they'll appear on top and in front of the houses. Does that make sense? Yeah. Okay, those were a nugget. Yeah.
One question about agents, multiple agents and different layouts.
Yeah.
You were talking about one of the things that we were going to do in another model was have one group of agents random and another group of agents in a what's the rigid one, the layout, the ordered one?
The ordered. Oh, you mean arranged?
Arranged, yeah. So we wanted
in a regular grid.
One arranged is one random. That's not.
What you can do is you could put them in a separate object that's embedded, and then that separate object will have its own environment properties. Yeah. Yeah. Okay. So, folks, are we comfortable with this? We're going to push on. Okay. So, folks, now we're gonna have some interactions. Okay. So, ladies and gentlemen, I'd like to go to person. And we're going to lend that person a home affiliated with them. We want to tell them their home. When they're created, we want to tell them which home it is. How would we do that? What would we add to that person? What is it that both encodes assumptions and communicates those assumptions? From the point of creation to the parameter. So we want to go to person, and we want to add a parameter to them that's going to describe their home. And we're going to call that parameter home. And ladies and gentlemen, of what type will that parameter be? It'll be a home. We're going to give them a home. We're going to make them associated with a home. Okay? Sure.
When you set up agent type, instead of clicking finish there, if you click next, they don't actually allow you to set parameters right in there.
Indeed.
Is there anything wrong with doing it that way?
There's nothing wrong. It's just I don't like teaching it that way from the start because I like people to feel empowered that they can go in and change things and they understand how that model is built. That's a fine way of doing it if you know what you're doing and you're comfortable sort of just delegating that to any logic. I just want them to know at a fine-grained level how things are working and interacting. But yes, there's all sorts of sophisticated things. You can assign visual representations, which are quite compelling. And maybe I should show that at some point. So I appreciate you mentioning it, George. Okay, ladies and gentlemen. So this is a home parameter, and we're going to have to assign a home to each person. So ladies and gentlemen, where do we go to if we want to assign? If the people have a home, they have a home parameter, and we want to now assign values for those homes. We want to give each one a home. Where do we do that? So we do it where in Maine? In the population. Remember when we gave people incomes? We had to assign their incomes, and we did that in the population with which they're associated. Remember we had to assign their ethnicities, and we did that with the population. So we need to go to Maine, indeed, and we need to go to the population in Maine. And you'll notice there's a field now for home. Why is there a field for it? Because it's a parameter of the person, right? So what are we going to say? We're going to say homes.random. Okay? So that will pick a random one among the homes and give it to this person as their home. Okay? Does that make sense visually? Okay, so now let's run this thing. So we should be able to, how can we drill down to a level of a person? Using this thing here. You notice there's two populations shown here now. Let's go to the population. One is population of homes, one of people. Let's go to population here. And now let's go, look, and you could see this person number 0 in the population is associated with home 146. This other person, number 1, is home 212. This other person, home 212, this second person, home 236. 400 homes, 1,200 people. By the pigeonhole principle, there's multiple people in given homes. Okay? Are people comfortable with that? Are you okay with that? Okay. Ladies and gentlemen, we're cruising right along. No bat problems here. Okay. So, ladies and gentlemen, I'd like now to add in a state chart to the person by which they're going to be going between two states. And this is going to be extremely abstract and abstract away from the condition. They're going to go between a healthy state and an ill state. Okay? Very stylized, but it's going to capture the essential features of the situation, which you folks can adapt to your conditions of interest. Obviously, we could do it for SEIR type context. We could do it for a context of a chronic disease like diabetes, as we have before. But let's just do it at a very abstract level because we've seen this before, and I don't want to spend undue time with the details of it. I just want to get the essentials in so you see how to build models with mobility and then hybrid models. Okay? So, ladies and gentlemen, how do I add a state chart to person? I'm sorry? Okay, yep. We've got a person. We go to the palette to the state chart items, and we want to drag in an entry point called health state chart. Okay? This is going to be one of two state charts. There's going to be later another one for care seeking. And let's drag in a state for healthy and drag in a state for ill. Okay? Okay? And we're going to set a transition between these two with a chance of 5% per year that someone becomes ill. How do we do that? Okay, a rate transition with a rate of what? 0.05. Okay? That's great. Now, I'd like to set a return transition that soon is going to be dependent upon the care conferred. But for the moment, it's going to be it's going to be called a cure transition, and it's going to occur after a certain just make it a rate of 0. We'll make it a rate of 1. That's fine for now. So later we're going to set it so that they're going to receive care at a facility, and that will allow them to be cured. But for now, it's just a rate transition. Okay? Okay? And this one here is going to be becoming ill, drawing ill. Okay? Okay. Very stylized. And again, we could go on and we could adapt it for a particular condition, but our interests lie in other aspects of the situation here. So I'm just going to leave it very stylized. Okay. Ladies and gentlemen, we want to color this person according to their health state. How can we do that? This is rehearsal. Add a variable. Yeah. We'll add a variable. It's not a parameter. It's not something that's given to them and stays the same. It's a variable, something that changes over time with them. So I'm going to call it color. And what type will it be? So we're going to drag it from the general palette here. It's going to be other, and it's going to be what specifically? It's going to be color. So you folks are on well-trodden ground. We haven't done anything different except we have that extra set of homes right now that we're going to be coming back to. Okay? Good. Ladies and gentlemen, how could we make it so that when they're healthy, they appear green, and when they're ill, they appear red? Okay, how would we do that? Entry action to healthy, we're going to set their color to be green, and the entry action to ill, I'm going to set their color to be red. Red, okay? There we go. Okay, and what's the final component of making them have a color visually? We have to set the color on their visual representation. And normally we would go do it here, but we actually can't. Where do we have to go for this sort of icon? Where do we have to go? I showed you yesterday. In person, we have to go to presentation, expand person, go to shape body. And finally, here we can set it. And I'm just going to set their fill color to be color. Okay? This is well-trodden ground. We've done it the past several days. Are people okay? Okay? Who needs help here? Who needs help? TAs? TAs ready to help? Okay, help over in the corner there. Kurt, to your left. Help in the center zones. Okay, central sectors. Okay, where are other TA resources? Okay. So, Kurt, if you could handle Dr. Doroshenko there.
So just on the entry point is where we put a green.
Green, yeah. And then we put a semicolon?
Okay.
One of those guys, yeah.
And then
Actually, yes, you could do it there, or you can do it, actually, you should do it here. So instead of the entry point, equals green, yeah. Green, yeah. Good, good, excellent. And then this one equals, no, the enter. Yeah, that's good. Yeah, okay. Folks, yeah.
The different icons, sometimes you can't fill them with a different color.
Oh, okay, right. No, that's correct. So
Maybe able to just
okay, so broadly, for different icons, some icons will allow you to specify the shape, the color immediately, the filler color by selecting it. There'll be a choice in the properties for fill color. Others of them will be composed of pieces, and you have to expand it over here to the requisite pieces and set it from there. I would suggest using the same icon. You might be able to, if you can find a way, that's great, but if you can't, you can use this icon, because it will be important visually. Okay? Okay, ladies and gentlemen, I'd like you to run your model if you're feeling comfortable with it, and you should see something like this. Okay? Okay, who needs TA help? Are we in a comfortable zone? Okay. Okay, folks. Right. Okay. Okay, ladies and gentlemen, I'm going to now do something, again, different. I'm going to add a new clinic class to the model. So I'm going to add a clinic to the model. So we're going to have a population of homes, a population of people, and a population of clinics. How would I add a new clinic class? Yep, new agent type clinic. Okay? Clinic. And we want to lend the clinic also a visual appearance. Okay? And let's scroll down here. And the one I'm going to choose for the clinic is going to be this little one that says retail store. Because, I didn't know what other, I didn't find a better looking thing. We certainly wouldn't want a factory or a fighter jet. And hopefully not a warehouse. Okay, so it's a clinic we've added in. A clinic to our model. A clinic has this visual representation which is shown here as a retail store. Ladies and gentlemen, I'd like you to add a set of clinics to the population, a population of clinics of size 3. How do I do that? Go to main, drag clinic in, call it clinics, make it a population of agents of size 3. Okay? That's great. Okay. Good. And now I'd like to run the model. Okay. And you should see some people going between different health states. You should see some homes, and you should see some clinics. There are 3 clinics scattered throughout the city. Okay, are we comfortable with that? Okay. We're closing in on our query. Ladies and gentlemen, we are now going to create a representation of care-seeking behavior on the part of individuals, whereby those individuals will present for care at the clinics. Okay? So, we're going to add, how could we, ladies and gentlemen, within our model, capture the fact that people are in a state of care-seeking or a state of being under care or a state of not seeking care right now? We could do a state chart. Yeah, so let's go create a separate state chart, separate from the one. There's one about their underlying health state, but this is different. This is about whether or not they're seeking care, and that will be somewhat dependent on their underlying health state. It's not totally independent, but it's decoupled enough we describe it with a different state chart. It's not one and the same thing. So we're going to have a care-seeking, and I'll put care-seeking state chart. Okay? There we go. Okay? Ladies and gentlemen, This state chart will have 3 states. One of them will be a state that's called not seeking care. One of them will be a state called in transit to care. And I'm going to drag it, for artful reasons, I'm going to drag it over to the side here. So this is going to be in transit to care. They're seeking care. They're not there yet. So they can't actually enter in the care process. And then there's going to be an undercare state. Undercare, where they're actually involved in a care process. Okay? Okay, ladies and gentlemen, I am going to then have a set of transitions here between these states. So we're going to have a transition from not seeking care to in transit to care. Okay? And this is going to be a transition that's associated with it's going to be a rate transition, and it's going to have a rate of 0.5, and it's going to have a guard associated with it. Can you tell me, what does this guard do? Yeah, it's a condition that has to be fulfilled for them to go. And the guard is going to depend on their health status. The guard is going to say whether or not they're healthy. So it's only if they're unhealthy that they're going to leave in transit to care here. Now, in general, we could represent a situation where you have a certain probability if you're healthy going seeking care. For the moment, we're going to confine ourselves to those who are actively ill. Okay, so here we could have a guard transition, and this guard is it's only going to go if someone is in the ill state. How would we test that? We've done it before when we've computed statistics. What would we ask if we're in the ill state? Okay, what would we ask? What in our model knows about a person knows if they're in the ill state? It's the state chart. Yeah, the health state chart, health state chart, dot is state active, and we're going to ask, are they ill? Now, just to prevent you from getting confused about when you have to say person dot, you could say person dot ill. Okay, that's fine. Yeah, it's complaining about this guy, but it's otherwise a happy camper. Okay. Okay. Yeah, there we are. This health state chart, I'll put it up on the big screen. So basically, we're only going to go to seek care in the event that right now that we're ill. Now, what we could do in general is, okay, if we're ill, there's a 90% probability we're going to be, or there's a higher rate if we're ill than if we're not ill, and we could represent that with 2 transitions, one guarded if they're ill and another guarded if they're healthy. One, if they're ill, they'll have a chance of 0.5, 50% chance per year. Otherwise, they'll have a chance of 10% per year. We could easily represent that with another transition here. Okay. Yes, Alan.
Could you also somehow put this state chart inside the ill state on the other state chart?
Yes, you could. If we wanted to purely logically subsume it within ill, yeah, you could do that. You could make it a sub-state chart in there. That's a good point.
Could you also use a transition from ill to
Again, if it was purely, you could, but the problem with that is we'd like to have a crisp way of asking, is a person ill? And here we would have to ask, are they ill? Okay, well, are they in this state or, this state or this state? Are they in that state? It's kind of cleaner if you have it separated into two pieces, but you couple the pieces. Then you can ask, okay, are they ill? And if you're interested, you could ask about their care-seeking behavior. But this is separated out so if you don't need to know about it, you don't have to ask. Does that make sense? It's sort of it's related, but it's distinct. Okay? Okay, ladies and gentlemen, so here we have a care-seeking behavior. And again, we could capture it for healthy people as well by having a parallel state chart. So that here they have a 50% chance per year of seeking care if they're ill. And we could have a similar thing if they're healthy. They have a 20% chance per year. Okay? Okay, ladies and gentlemen, I'd like now to go, and we're going to put in place something here, that same transition that we've not done before. And we want to take them to their clinic, to a clinic with which they're associated, okay? Now, there's several different ways we could implement this. My preference would be to do it in a certain way, and we're going to do it that way, but bear in mind there's other ways to do it. So I'd like to add another variable to our model called nearest clinic. Nearest clinic, okay? And what do you think the type of that variable is going to be? This is from the General tab. We're going to add this variable, nearest clinic. What do you think the type of that is going to be? It's going to be a clinic. Okay. Okay, folks? Now, over here in the care-seeking state chart, ladies and gentlemen, I would like to go and for the action for this entry, we're going to get their closest the closest clinic. Okay, and I'd like to go to do this in the following way. So in this action, we're going to say nearest clinic equals this. Who is this? You can tell me. It's the person at issue who's getting into this state. This dot get nearest agent, and from which group of agents are we picking them? This dot main dot clinics. We're going to get our clinic as the nearest one of the set of all clinics. I'll put it on the big screen. But I'm going to add one line to it first, because there's another thing that I actually want to do as well at this point. I want to jump them to their home. Right now, people are not in their homes. So I want to jump them to their home. So I'm going to say this dot jump to, okay, and where do I want to jump it to? To their what? To their home. So how would I get the X location of their home? Okay, you could say this dot home dot get X, this dot home dot get Y. My home, I'm going to get its X location, and then I'm going to get its Y location, and I'm going to jump to that point. And this, Alex, I will put on the big screen. Okay? There we go. So, when they first come into this care-seeking state chart, I'm going to jump them to their home, visually, and then we're going to deduce their nearest clinic. And guess when they're going to go to their nearest clinic? At what point will they move to the nearest clinic? when they exhibit care-seeking behavior as a result of being ill right now. Okay? We're gearing up towards completion of this. We're most of the way there. Just got a little bit more to go. People okay? People okay with this? Okay. And we're going to finish this model after lunch. And we're going to do so in a hybrid way. It's going to be a hybrid ABM-DES model. Yeah, I defined it the variable nearest clinic. Nearest clinic, and it's a clinic. Okay. Okay? Are people comfortable with going forward from this? Okay, so ladies and gentlemen, having done that, you tell me, what should I put into this? When they're just leaving in transit for care, what should I put in here? Think about that movement we saw earlier with the bats. Think about the movement of the bats towards our mouse when we first clicked on it. Yeah, we're going to move to the nearest clinic. So, who are we going to move? This, ourselves. This move to, and to what X location? To the nearest clinic's X location. And what Y location? The Y location of the nearest clinic. Okay? There we go. I'll put this up on the big screen. There we go. Oop. I'll put it on 2 lines so you could see it. That's for going to in transit to care. Okay? In the transition to in transit to care state. It could also be in the entry action for in transit to care, would be another place to put it. Okay? Okay, you're starting to see some action. Okay, great. Ladies and gentlemen, I think some of us are already jumping ahead. Good, that's great. Okay, ladies and gentlemen, so you tell me, based on our experience, they're in this in-transit to care state while they're moving. Under what conditions would they actually be under care? When they do what? They're moving to the clinic, and at what point can we say that they'll reasonably be under care? When they arrive at the clinic. And how do we capture an arrival in any logic? An agent arrival transition, right? We can capture that in our state chart. Do you remember that? Remember we saw it with a flapping bat? At least we like to imagine it was flapping. Okay. So we're going to have an agent arrival transition. I'll try to leave this up on the screen for those. We're going to try to have an agent arrival transition here. So its transition type will be agent arrival. And at that point, they'll be under care, right? And ladies and gentlemen, for the current point in time, till after we leave lunch, you may be yearning over lunch to get back to this, to take it to the next level, because we're going to be starting to represent actually nurses, healthcare workers interacting with the patient after lunch. But for the moment, when they're under care, we're going to have them leave via another transition going back to their no longer care-seeking state after some fixed time. Okay? So we're going to add in a transition here, which is going to go back from under care to not seeking care. Okay? And that transition is going to be completed care, okay? Or exited care, and it's going to be a timeout. they might have balked, it'll turn out.
Fair enough.
They might balk, they might say this waiting time is for the birds and leave. Yeah. So if they're an emergency department, they may decide, it's going to take too long because they're being triaged and there are minor complaints. Yes. Sure. Okay, the final thing we want to do here, though, the final little tidbit here is hopefully what has happened as a result of the care. They've become better. So hopefully they are now no longer ill. They're going to transition to the healthy state. And how can we make that happen? How could we make a transition fire? By sending a message. Okay. So, ladies and gentlemen, we're going to go for this transition here. We're going to make it depend on a message. Okay? And this message will be the message cured. Oops, sorry. This will be, if on a particular message, will be the message cured. And under that message, they will go back from ill to healthy. And what will happen after they have conferred their care? What's going to happen here? When their care completes, right now we're going to assume that having exited care, that they have been cured. So we're going to send this other state chart a message saying you've been cured. Okay? We're going to send it a state chart. This dot health state chart dot send or dot receive message, and we're going to send it the message cured, just like that. Okay, so here we're going to have someone present, and I'll walk through each of these transitions, but big picture, they're going to leave to present for care if they're ill, with a certain chance per year they'll actually try to come under care. They're going to be in transit to care, just in terms of moving. When they arrive, they'll be under care, and after a certain amount of time, they will go back and no longer be seeking care. Okay? And the way in which they'll, in the way in which this is going on right now, when they return, we're going to, at that point, we'll send them a message that they're cured, and they're going to hopefully go back to the healthy state. The one thing I want to say is the timeout here, let's make it after 1 day of care. So we'll do 1 times day here. Okay? The timeout will be 1 day. Yes, Alex. Question. Okay. Question?
You just answered it. It was the timeout. I was thinking it would take a year.
Yeah, no, it's going to be 1 day. 1 day of care. Pretty good deal. Yeah.
Don't you need to move them back to their home?
Good point. Yes. Excellent point. We're going to have to set it to return to their home here. Yeah, excellent point. Good. So what we will do here is we will move them to their home, okay? And how would we move them to their home? Could anyone tell me? This dot move to, and what would I type? We need the x-coordinate. How do I get the x-coordinate? This dot home dot get x, right? We're asking the home's x, the home's y, right? Oops, get y. Just like that. And that's what will allow them to return home. Okay, so per request, I'm going to go through each of these transitions. The first is the transition in here. Oh, I'm sorry. Okay. Okay, so this is the big screen. So move it up? Okay, sure. There we go. Sure.
So
Sorry? I see. Okay. Let's make it not so big screen. Okay. Okay. If you want, I could show one in the bottom, one in the top. Do you want me to do that? Okay. I'm going to show this first one on the top, on the bottom, and this one at the top. So the one at the this one here is entering the state chart. We're jumping to their home, and we're getting their nearest clinic. This guy here is when they're done with their care, they're going to move home, and they're going to be cured. Okay? Okay? People okay with that? Who needs TA help? Okay? So let's just go through this again. Bunch of what? So the network crashed? What's going on? This is really interesting.
So in some computers it was in a loop saying not responding.
Okay.
So when I clicked on this, it just went into gray out the screen and loop and says any loop is not responding.
Can anyone show it to me right now? I just came back. I'm guessing it's a network problem probably, but okay. Are we back in action? Okay. Ladies and gentlemen, I'd like to go through these steps again. This first one, coming in, we jump home and we get our nearest clinic. This one here, we have a rate of 0.5. We move to the nearest clinic, but we only do so if we're ill. We're in transit, and when we arrive, we're... Okay, sure. Why don't I start again? I'll put them up on the big screen. So here, coming in, this is what's happening. You're jumping to your home for the first time, and you're setting your nearest clinic. People okay with that? Okay. Anyone want it up longer? Okay. This one here, we're moving to, we're going with a rate of 0.5, 50% chance per year, we're going to move to our clinic move to our clinic, and then we're only going to do so if we're ill. We're only doing so if we're ill. Okay? Oh, sure. This is departing for care. Yeah, but you're actually departing for it at that time. And this transition is arriving at care. Okay? Something like that. Okay. Departing for care, yeah. Sure. We're moving to the nearest clinic. It's this thing up here. Yes.
Does it matter if you're finding the nearest clinic in the departing for care transition versus the starting point for the time?
Not a lot, but there are certain situations where either might be favorable. In this case, it's nice to only have to do it once for each person to figure out. So we do it when entering, and then you've only done it once, and that's it. But if like someone's home was changing around over time, maybe their nearest, or maybe more clinics are going to come in, and maybe you want to do it every time you going to depart for care, you're going to check, is there now a nearest clinic? And so you might do it in that other way then. But it can be done either way. So, yeah, Serge. Okay. They should have a rate of becoming ill, according to this, to become ill again. But sorry. Let's go see. Let's go see. Okay, here they are, moving to the clinics. Okay. Okay, now they're going out from the clinics. Okay. Okay, now that's interesting. Okay, now we have a bunch of people who are ill, so they should be able to seek care. Okay. 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 I have a theory as to why this is, and we'll put in a self-transition here. Okay. We're going to put in a self-transition here. It's going to go off once per month, and I have a theory that will resolve the issue. I think the guard is probably only being evaluated once. I think that's the issue. Okay, so now let's see. Nope. Okay, so now let's try taking this out. And I thought it didn't matter in any logic 7, but I may be wrong. Okay, so here we go. Here people are going for the clinic. They're coming back out. And that worked. Yeah. Okay. Okay. The difference is that going out, it actually is going to recheck this guard to see if it's the case every time. Whereas if you just do it an internal transition, it's not gonna re-enter the state. Therefore, it's not going to re-examine the guard, and therefore, if it determines that the guard was false, that you're not ill, even when you become ill in the other state chart, it's not going to wake up and recompute that. So you do need this external transition every month. That's going to tell it essentially recompute whether or not I'm ill. That's sorry. 0.1. Yep. Yeah. Yeah, it's 0.1 here. 1 times month. It's this is a transition from not seeking care to not seeking care. It's a transition that basically says that we're it basically gets it to recalculate whether or not I'm ill, re-examine whether I could be departing for care. That's unfortunate. It can be done in a more elegant way then, if you have to do it that way. So really what should happen is, it's a timeout of 1 month, every 1 month. 1 month. What's the name of it? So it's re-examine health status. I don't like that. We'll do it better after lunch, but that does work for it. Yeah. Okay. 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 So here we have people going through this process. They go between healthy and ill. Those who are ill depart for care. They go in transit to care. They arrive at care. They're under care for some period of time. And then they, once they are conferred care, they're cured. It cures their ill health, and they move back home. And hence you see this sort of flow of individuals here to the clinic and a flow of individuals away from the clinic who are healthy. People become ill over time. They present for care. The clinic sends people back who are cured. Okay? Okay. So we're going to be going to lunch now. Following lunch, we're going to be going through this model, and we're going to be enriching it to actually represent the care process they receive at the clinic, and whether or not they're actually conferred proper care, whether or not their underlying health condition is resolved. Okay? But here we have people's movements to the clinic, movements back from the clinic to home, back and forth, and their health status changes as they move. Okay? Okay. Very good. So, we're going to go to lunch. There's going to be guest lectures by TAs during lunch, right? So Priyasri and Winchell will be giving guest lectures on some tools that work with any logic.
Mine looks more like green. But over green. Did I do something wrong with the healthy chart?
Let's check. So the
it
circles
looks
are
sort of opposite of what yours is.
Oh, interesting.
So did I maybe
You've got
reverse
more. I think you've got.
Did I reverse something that links one? What did we do that links this one to this one?
We cured them, so we sent them a message associated with this that says that they're cured. But go and check this guy here, and that's based on that's a rate. You need to make that a message transition.
Okay. And then there's.
And it's on a particular. Well, it will be on a particular message cured. The same message you sent before. Yeah. Okay? Okay? Sure. So they're presenting for care, and then they're leaving. You'll notice the folks, if you slow it down, you'll notice the folks coming towards it are red, and those going away from it are green because they've been cured.
Cool. Yeah.
That's like the dream of the healthcare system.
Right.
Word only so. Right.
Yeah. All right.
Yeah.
Excellent.
Okay?
Cool.
Yeah.
On the earlier problem that we're having with the slider bar,
Yeah.
I changed something in it where I moved in the agent where it was doing the move, and then I put the update speed afterwards, and it worked fine. But,
Really?
But when the only issue is that when you set it to 0, so basically if you set it close to 0, some of the people move slowly while the others start moving fast because they've already reached their location.
Right. Right.
But if you set it to 0, the people start disappearing. And like the agent would just disappear, but it's like, because then it's saying, it's almost like saying, oh, these people have 0 velocity, then you try to make a new move, and it's like, oh, they can't move, so they just somehow vanish in like a singularity or something like that.
Really?
But the
Okay.
slider, the rest of the slider works as long as it's not 0. So,
But it does take until they arrive to sort
so
of.
basically, yeah, you then have, if you move this thing, you have some of them moving
Exactly.
slower while the others are moving faster.
Until they reach their destination, and then they speed
I
up.
don't know why the people are vanishing. So I assume, again, something to do with the way that it's figuring out inter-arrival times or something like
Indeed.
that.
Yeah. It just doesn't make sense to me why it would be a problem with that. Really that really troubles me. All I can say is I think it's a bug.
Yeah, because I also messed around with like some of the memory stuff just out of interest.
Yeah.
So sometimes you can get it with the original way we had it done. You can move it around and it worked for a few of them, and then it's like a final move happens. So it's like you can process it sometimes. Right? It's almost like it's trying to run.
I mean that's along the lines of some of my suspicions too. So if I go open this, let's go check this out. One theory I have is this is a. I'm hoping this is not the case, but maybe this is some sort of threading issue. So I'm just going to have a velocity, and I'm going to link this. This would be like current velocity. And I'm going to link it to this guy rather than, I hope it's not this, but I just want to do a sanity check. So I want to link to current velocity, okay? Okay. And now I want to go through and I want to set directly their velocity, right? Yeah. Let's set velocity, current velocity. It can't be this, but pardon me. Let me. Yeah. I mean, as a sanity check, maybe it is, and I'll be unhappy. Okay, so we don't need this thing anymore. What a problem. Okay. And then when they arrive, then they come back into this, and they report. Okay, fine. So let's go run this thing. Okay, so fair enough. No. Okay. No. Yep, it's still reporting this, and it thinks the velocity. This is like the first one with the alternative velocity, right? That's the thing.
Well, you're getting that, but I'm not getting that. I'm getting sometimes that it's not the first person.
Really?
Yeah. Like sometimes I'm able to make changes too. Like it will work for one change, but it won't work if I try to make 2 or 3 changes.
Yeah. That's. And the other thing was, I would have thought that it would definitely work with this. Current velocity. Would have thought that it would definitely work if you sent a message instead, because that would have made it pop out and recalculate its arrival time.
It's making me suspicious that it is something to do with threading, because that it's sort of maybe doing some kind of random ordering or how firing off the commands.
Which it may, because it's visual properties. Those run in a different thread, I think, than the underlying.
I know, because there's options in like the main. You can set like the CPU for like visualization to.
Exactly. Yeah, you could basically throttle it so that it tries to keep up with the underlying simulation. And, see that doesn't work either, and it just doesn't. I think it's probably some sort of threading thing, where the thread is not being woken up.
What if the slider makes it to go out, and after go out in the transition, you reset the velocity and then come back, and then when you come back, it'll reset this.
That's what I tried to do. I tried to get it to go out with this when it received this message, and
then reset.
And that would reset it. Well, yes, it would reset it there. So when this was adjusted, I had it go through the bats and send them a message.
So it'll go out.
And then it goes out here and comes back in. It sets the velocity here, which should allow it when it comes back in to do this.
But
it's still not working.
Weird.
Isn't that weird? I'm quite confident that would have worked in AnyLogic 6 just fine. And actually much easier. You could have just set it directly. But
I think they've changed something that threading, the way they do threading in 7.
Yes, yes, I think that's true. But you're right, though. Look at this. Here it changed all these to 20. It was fine. Changed them to 30, and then just one of them got it.
Yeah.
It's like an arbitrary one. So I think it's some sort of threading issue.
Yeah.
There's some sort of
I assume
inconsistency.
there's like some way that it wouldn't be very pretty, but you could probably like explicitly force it to try to do certain things in very sequential order, but then you're kind of destroying the continuous nature of it.
Right.
So.
Exactly.
But yeah, there's obviously something wrong with their methods too, because, like I said, it's destroying agents if you do it in that particular order where you say move, then set velocity.
Yeah,
and
it doesn't make
it's
sense.
going. There's no now. You're not going to be able to move there in time. I'll just get rid of the agent.
Right.
But the agent's still in the population. It's just not
Visible.
It's not visible. So.
Yeah. So I think this is a bug. I think they have a bug in there. It doesn't make sense to me why it would do this.
Because I want to get it fixed because I have a similar problem in my hospital simulation. I'm trying to slide the bar and change the number of beds during the simulation, and I made some sort of dodgy workaround, but it was just breaking all the time. So I just thought it was me because I had no experience with it.
This is 6 or 7.
7.
Okay. Yeah, my suspicions. I think maybe Dylan or Kurt could look at this and just this issue with the slider breaking it. I think it's a threading issue. I think it's a separate visual thread that is handling the visual movement and is handling this. It doesn't make sense to me why this wouldn't work. I mean, I've tried it a bunch of different ways. The key way about this is it should be able to recalculate its transition.
You'd think, but Asian string, continuous space.
Yeah, see here? If the agent is moving, it will continue moving from the current location with the new velocity.
Yeah, and then the other one was
So-
move to.
If the agent's not moving,
Yeah,
it will
don't
not
do move. Don't do that. That's the move to and the
Oh,
other.
there was a phrase says if it's not moving, it will not start moving
Yeah.
until
Yeah.
you call move to. So is it
Yeah,
because when we
given
set it to
velocity
0
can
and
be
then
changed dynamically. On arrival, action when and if reach start.
But it does occur when we're not setting it to 0. Too. Yeah.
Is it a property of the slider bar? Would it work just like
I know. If you set it manually.
no, just had like a button say just move from 2 states. Is it something because like the slider bar trying to figure out where it is as you're sliding it across?
I actually encountered this issue in AnyLogic 6.
Did you?
So
Really?
I'm really surprised that this is still an issue.
Really? With visual?
Oh yeah,
Huh.
it was causing one of my like little speciator simulations to work.
But it's clearly trying to recalculate the new arrival time with the velocity bar.
Yeah. That's really
It's
strange.
breaking the value. There's got to be a reason.
Shoot.
Right.
Whatever the case, looks like we're like 50 minutes late for lunch.
Exactly. I've got to get over and present.
So
I mean,
maybe
I've
we
got to
should-
get over and rather introduce them. So.
Shall we go move everybody down there then?
Oh yeah, I think most people have gone.
Oh, okay. I just saw half the people still sitting here. So I was
Yeah,
like,
yeah.
Okay.
No, I think I announced that we're going over to lunch. So.
Okay. Well, I guess we'll head over and
Great.
come back.
Oh yeah, yeah. But great to have you here. So the student, he's back on Friday, is that right? Yeah. That'll be great. Really? Oh, this is the older one. Yeah, that's great. Yeah, I mean, I'd be honored to think about, co-supervising with you. Let's see what his interests are. It'd be great if you can make it. Friday will be, because people have gone through all these things, it might be a bit hard to fit in, but if you give it a try and see. Great. Terrific. Oh, well. think normally we've closed it up over lunch. If people leave the room, if you could close the door after you, if you're the last one. Folks, if you're gonna leave the room, please close the door after you, if you're the last, okay? And I'll make sure I'm the last. I have the keys, so. Okay. Alright. You're presenting, right? For lunch? Okay, Alex. Oh, no. Oh, where is the projector? Sorry. Okay, so it hadn't been set. Okay, I got that. Sorry.
There was a woman, she forgot to do a power bar for her computer last night, and she didn't pick it up, or for power plug-in.
Sorry?
For power cord.
Who?
That was mine. It was yours?
Yeah.
I came and got it. So I emailed the wrong person.
Sorry, I had to bring my, tell you what, why don't I bring that over? I have to go on a bike. Thank you.
Close that door.
I have to get over there quickly. So Winchell, is the screen set up there or no?
No.
The screen haven't been quoted. Oh, I see.
Sounds good. You can turn it up there. There's a button. I'm testing the phone app just to see if it crashes when I'm running YouTube. Alright. I made some good changes here on iEpi.
Good.
Seems to be not getting in the way of YouTube usage.
Good. Good to check that. Okay, I gotta,
See you
like,
there.
it's a bat out of hell. Hello.
Why is it written that way? Why is it sending? Why is it receiving and not sending? Is that the state that it's sending? I'll bring it up and we'll read my phone. But I've been thinking about that for the last hour. I don't know.
Yeah.
I put inside event. Event
Uh-huh.
0, and you just change it.
Sorry?
I'm in the slider. I put an event in main.
Okay.
Yeah, and you just put, for example, you remember this moving the bat?
Uh-huh.
We had a problem with it.
Yeah.
I just defined the, just put event in main,
Uh-huh.
and from main I change the x and y, and in terms of sliders values, because the event is always working. Yeah. Event.
Yeah, no, I know what you mean in event. Yeah.
I
Yeah.
put just the code, for example,
Yeah.
set x and y or whatever,
Yeah.
and inside the event, and inside velocity. And
Set
you-
velocity
Yes.
in the
yes.
event.
Yeah, and just velocity was just changing from the slider. When you change the slider, because the event just is a just kind of loop, yeah. It's
Yeah.
working just.
Okay. So the event did what?
Yeah, it's more.
No, but what was the event doing?
Wait, it's.
Okay. It's probably best. No, I don't think I do. I've got to get things ready here. So.
But anyway, you put event in main,
Yeah.
and inside event,
Yeah.
you just put set velocity,
Uh huh.
and the value of velocity comes from the value.
slider.
Yes, that's all.
Yeah. See, it doesn't make sense.
Why? Because inside.
No, but it doesn't make sense. You can't do it. According to the documentation, you should be
Okay.
able to do it the way we did it. Though.
Yeah, I mean, okay.
No,
okay.
I'm saying it's a bug in any logic.
Oh yeah, I got
Yeah.
it. No, this I mean
Yeah.
this is just solution.
As a workaround.
Yes, yes.
As a workaround.
Yes,
So you're saying this event goes off and it sets the velocity of every agent based on.
Fine, we have a for loop here.
Yeah, yeah.
Yes, you just put a for loop and it's
Yeah.
like
Yeah. 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 Okay. That's interesting. I'll like to look at that later.
okay.
Yeah.
It's gone back to, yeah, sure, please. It's gone back to the.
While you're writing it, can I get something to print?
Yeah, sure. What are you answering?
Well, I need to go online.
Excuse me? You go online. Oh, yeah. Something like that. There's nothing to tell everybody. We have the null pointer. Oh, yes, smart, smart.
Okay. So before we move on to additional material, I wanted to go over aspects of this model. I understand. What's that? Sorry? Oh, sure. Yeah, why don't we do, sure, there's a couple people still not here, but. You gonna be here for the next hour? Yeah, why don't we do it after this next little bit? Because, yeah, there are a couple people missing still. So. Okay, folks, so the model from this morning should have yielded a situation that looked like this. We had various people in the population. That population becomes ill over time, and they turn from green to red. So maybe I'll record this so it's already